All right. Hi, everybody. I'm Adam Cook. I'm a PhD researcher in the Center for Doctoral Training in the Computational Foundry. And I'm going to talk to you primarily about my master's thesis. I know some of you might have seen this presentation during that. I have slightly changed it and adapted it for this talk. So I just want to introduce basically the field in which I'm working in. Very briefly. So as I say, I'm currently studying for a PhD in classification and extremist content. And so I'm working alongside a stakeholder trying to produce machine learning classification technology to help enable sort of automatic detection of extremist content. And I want to just briefly state why this is an important thing. So on screen, you can see a few of the big social media networks and some that don't even exist anymore, like Google+. But the important thing is here, there's what, like 10 social networks. But in reality, there's actually so many more. There's hundreds and hundreds and hundreds of different tech platforms, most of which you won't have heard of. And whilst terrorists do use these platforms to communicate on, particularly Twitter and Facebook and Telegram and things like that. There are also hundreds and hundreds of other platforms which they also use. One of the most famous ones is a platform called Just Paste It. It's run by one person, and so there's an awful lot of small platforms online which just don't have the capacity or don't have the resources to be able to effectively and really quickly deal with terrorist content. And as the media is focusing more and more on these kinds of uses of social media, particularly after like live streams of terrorist activity and things like that, there's been a greater and greater focus on these platforms to try and get them to remove content as quickly as possible. And so therefore automated techniques are a necessity to achieve this reality. Content moderation is, of course, hard. It's hard, particularly if you don't have a large content moderation team. So having some automated system to sort of sift through the data and at least make a preliminary decision, if not the final decision, is useful. So I'm obviously going on to focus much more on this in my PhD. I'm focusing on a very small project that I did, which sort of is leading up to this broader work in my master's. So the basis of this research for my master's was a replication of this paper, detection and classification of social media-based extremist affiliations using sentiment analysis techniques. Now, I won't go too in depth on this paper, but I will mention a few things about this paper, and which is why we sort of decided it might be a good idea to replicate this paper's findings. So it worked on tweets. So they collected a data set of tweets and classified them into two categories of extremist or non-extremist tweets. Now, the paper very much has a computer science focus. It focuses very much on the technical specification of the research and doesn't spend nearly as much time on the sort of social science side. And I'll come why to that's important in a second. Now, ultimately, they achieved a 92.66% accuracy. That was their ultimate headline finding at the end of the study. Now, it's interesting because when you look at data science and machine learning research, a lot of the time, this is the key takeaway from papers. It's almost like your accuracy is the output of your research, but really, that isn't the output of the research. The output of the research is the model. It's the thing that makes decisions. So your output should really be the decisions that your model makes and not just the accuracy of your model. And accuracy is one good way, a sort of headline insight, but it isn't ultimately the only way to look at and understand a model. But one of the problems that we had when looking at this research was there was some unclear labeling. So in their pre-processing step, they talk about labeling things as extremist or non-extremist, but it's not exactly clear how they're labeling. What are they defining to be extremist content? What are they defining to be non-extremist content? And on top of this, there was some techniques that they used to sort of split these two. which use sort of automated word filtering processes in order to automatically label data. We thought that was a little bit weird and might affect the overall outcome. So we had, it seemed to be a paper that had a really good accuracy. It was one of the big deep learning papers we could see in the field, but we weren't necessarily sure how valid the findings are. We wanted to check that for ourselves. So how did we solve this? Well, we solved this via replication. And we decided to replicate this paper using two main techniques. So the first, we wanted to replicate it using its original context. So we reached out to the study authors, and they kindly provided the data set that they used to produce their initial findings. We then wanted to apply it to a new context. So we decided to apply it to a context of magazines. And I'll very quickly explain the magazines that we used in this new context. So the magazines that we used are sort of split up into two camps. The extremist magazines, and here we have three magazines: Inspire, Dabiq, and Rumiyya. And these are magazines created by terrorist groups, as is defined by the UK government. So IS and Al Qaeda created these magazines. Now, the magazines have slightly different focuses. Some of them are primarily to sort of spread the word of sort of their organization and their goals, and some of them are specifically trying to prompt action. We also looked at some non-extremist magazines. Now, in order to try and balance out and make sure that our contexts were appropriate and that we weren't biasing the data, we decided to pick a non-extremist magazine that was broadly, also talking about sort of Muslim scripture extensively. So we picked this magazine, Al Jamouya, and that essentially gave us a relatively balanced data set with an equal amount of data in the non-extremist camp and the extremist camp. And what we also have done since then is included this additional data set to try and see if that helped the decisions our model was making. Now, it should be said that we actually also used a relatively, simple way of labeling the data. We simply said, is the data in the extremist magazines? If so, the content is extremist. Otherwise, it's non-extremist. We'll come on to why that's a problem in a second. So a brief look at what the data looked like. So we could see we produced a few word clouds and also did some other analysis into the data sets. But you can see there's a few key things you can pick up straight away. It's words like war and soldier and brother. These are all quite big in the extremist context. And in the non-extremist context, we also have other words which are sort of bigger, occur more often: heart and life. And that sort of gives us an idea that there maybe is broadly differences between these two data sets. And that means that maybe it's meaningful to make a model that can automatically detect the differences. So I won't go over the model into much depth. This is a very, very high level, simple, overview of what the model does, but essentially converts the text into numbers, and then it puts it through a LSTM layer, and then it convolutes and pulls the data. So LSTM is just a good model for data which has a sort of order to it, like text does. And then convolution and pooling, those are generally good steps to extract features. Now, using the initial data that we received from them, we got a relatively poor replication. So on the original context, we got 73.1%. So this was in comparison to their 92% finding. And this was quite unexpected. It's still, to us, not exactly clear what the problem is. We have reached out asking for their code, but so far haven't received it. However, on our new context, on our own data set, we got 92.1%. Again, very similar to the findings they got on their own data. Now, this could be the fact that the data they sent us isn't necessarily the data that they got the findings on. Maybe there was a miscommunication there. But also, it could be that our data set generally is slightly wordier, right? We're working with magazines. They're longer paragraphs, longer texts. Whilst I tried to chunk them so that they were in similar lengths in both data sets, there could be differences there, and that's why we got a better accuracy. We also found no transferability. So I took the model train on my data and applied it to their data and vice versa. And we found that neither model had really learned anything on the other's data set. And that's interesting because at the end of their paper, they sort of come to this conclusion that we've got a model that can detect extremist content. But do they? If it doesn't apply outside of the context that they train the data on, how useful is it to say that it really does detect extremist content? Now, to sort of highlight this further, I've had a further look at my model on my data set. So here is a little snippet of text that the model classified. There's a few weird formatting issues and it doesn't quite make sense. That's just because of the pre-processing step. Now here's another snippet of text. What do you think it is? Extremist, non-extremist? Well, the top one is extremist. The model correctly classified it as extremist. That's good because it is extremist content. Although, it's difficult to tell. It does use words like attack and sort of enemy, but it's difficult to tell in the context if that is truly an extremist piece of content. I mean, it's not a lot of words, right? What about the bottom? Well, that's also extremist. And the model also correctly predicted it as extremist. Now, I don't know how many of you guessed it was extremist, maybe just because of the context in which I showed it. But yeah, it is extremist text, even though it is essentially just describing a train route. Now, obviously, within the context of the article, it's sort of trying to incite action, and that's the implication. But the text on its own, there's nothing extremist about it. But the model detected it as extremist, and we decided that that was a correct classification, and so that boosted the model's accuracy. But is that the correct way to go about classifying that piece of text? So I'll briefly go into the conclusions and then I'll open up for questions. So the conclusions we got from this research, there was too little context. We're only dealing with about 30 words. That's not enough to really tell on its own, if the content is extremist or non-extremist. Also a poor labeling technique. I don't think it's correct to assume that just because the content appears in an extremist magazine that we can label it as extremist or even terrorist. And the same goes potentially for non-extremist magazines. We also had too little non-extremist content. That's why it was labeling the train, text as extremist. It had only seen trains within the context of the extremist magazine. As I say, we then brought in an additional data set to try and expand our model's vocabulary. But the problem is you end up then diluting the amount of extremist data, and it ends up getting poorer results. So when we tried to level things out, it still wasn't producing much better results for us. We also need to better define terms. Just as we criticized the study that we replicated for, we also need to do that ourselves. What are we defining as terrorist or non-terrorist? What are we defining as extremist or non-extremist? And I think there has to be a much sort of broader look at that from a sort of almost social science perspective before you're even able to make a decent classifier. And there, I will stop sharing and open up for questions.